To understand this question, since they're going to be asking us about argon and K+, and they say that they're isoelectronic, which they are, right? If you come up here, potassium has 19 protons and 19 electrons. If it's going to become potassium plus, that means it's lost an electron, and now it's isoelectronic with argon. And they're saying that therefore, if these are, representations of the electrons in the atom, they're going to look exactly the same. Both of these atoms have 1s, 2s, 2p, 3s, and 3p6 electrons, right? They all both in there. So they're wanting to know, well, how would these spectra be different? If the pattern will be the same, of course, the peaks will be shifted a little bit left and right. And the idea here is that they will all shift left. There'll be higher binding energy in the atom that has the most nuclear charge. So what I would do is I would draw down some sort of stats about it. If you imagine that argon in its nucleus is going to have, well, its atomic number is 18, and whereas versus in potassium it's 19, well, right there we know that potassium has a more attractive nucleus. So all its electrons that are around the outside, whether they be in the first ring or the second ring, or I think both of these atoms have electrons in the third ring, you would expect these electrons to experience more attraction. As a matter of fact, I'm going to draw it a little bit smaller. The first, second, and third ring would be pulled in more. They'd be attracted more to that nucleus because there's higher effective nuclear charge, just because there's more protons. So now we know that the electrons in potassium will have higher binding energy. And the atom, incidentally, will be smaller, too. So let's look at their answers. Which direction are the peaks in K+ shifted relative to argon? Well, in K+, because there's higher binding energy, I think those peaks are going to be shifted to the left. They're going to be down here more near the high binding energy part of the graph. If we look at the next question, which of the following best explains this observation? Well, as we were just talking about, it's definitely K+ has greater effective nuclear charge. So I think the first one will be the correct answer. Let's see. I think B, K+ is a larger atom. No, we just said it would be smaller, right? Argon is a smaller atom. Nope, it's larger. Yeah, the rest of these are out. So I think definitely the first one.